This is a webinar on ModelMuse, September 16th, 2010. And ModelMuse is a free graphical user interface for ModFlow and FAST. This is an example of the ModFlow model that Dick Yeager has been working on. My objective when creating ModelMuse was to use, first of all, to use grid-independent data so that if you want to change your model to have a different grid, you don't have to re-enter a whole lot of data. I also wanted it to be easy to use, to be powerful, and to be fast. Now, these objectives conflict with one another to a certain extent. For example, having grid-independent data makes it slower because it has to figure out what each cell has to have. Making it powerful and fast also conflict. Making it easy to use conflicts with being powerful, because being powerful often means having more features, which makes it more difficult to learn how to use. So what do I mean by grid-independent data? Well, it means that data isn't stored in individual grid cells. Instead, it's stored in what I'm calling objects. Here's a point here, a point here, point here, point here, and the data is associated with those, and it's being interpolated across the grid. And then there's a polygon, and it's superimposing its data on the grid. When I drastically modify the grid by refining it in some places and rotating it, the data is still applied appropriately. All the cells inside the grid are colored properly. You have these data points, and it's interpolating among them. There are a number of things that make ModelMuse powerful. One of them is that you can use formulas to assign values to data sets. Here, for example, is the formula for the horizontal anisotropy. And you can see it's based on Kx, which is the hydraulic conductivity in the x direction, and Ky, which is our hydraulic conductivity in the y direction. So based on what those values are, it assigns a value for the horizontal anisotropy. You can also use interpolation. There are 6 different interpolation algorithms built in. I've tried to make ModelMuse easy to use. Here's an example of some things that can make it easy to use. I'm trying to enter data here for the river package. If you have this data in a spreadsheet, you could select the data in the spreadsheet, copy it to the clipboard, and paste it into this table. You don't have to enter one value at a time. You can select multiple cells and then just type a value here, and it assigns it to all those cells at once. You can use formulas for things like the river bottom. Here I'm using formula model top to say that the river bottom is just going to go right along the top of the model. Instead of specifying different things for each stress period, you just specify starting and ending times. And then if those encompass multiple stress periods, you've entered the data for all those stress periods at once. If they don't correspond to stress periods, ModelMuse can figure out that it needs to generate new stress periods to accommodate the times that you've entered. Now, the formulas are something of a double-edged sword because they give you an ability to assign data across the grid in an easy way, but they can also be difficult to understand. Now, here's that same formula we saw before, and to help make it a little bit easier to understand, in the formula editor, there's a box up here with a tree control that you can expand or contract or close down each of these branches, and you get a diagram of the formula. So here's an if statement. If Kx equals 0, then you get 1. Otherwise, you get Ky equals divided by Kx. So this means that you don't get a division by 0 error, which you might get if you just had Ky divided by Kx. But that's a little bit complicated, and I think this helps it be easier to understand. Sometimes a value will be assigned to a grid cell, and it's not the value you want, but you don't know exactly why. Well, this dialog box can help It's called the grid value dialog box, and it shows value for the data set, which in this case is called test. But beyond that, it also shows an explanation of how that value was assigned. So you can use that to figure out what's happened, and then you can deal with the situation. To make it fast, I've done a number of things. One thing is that the data are only recalculated when they need to be recalculated. For instance, if you're just displaying the screen again because you zoomed in or zoomed out, you don't need to recalculate the data. That data can just be stored and used to color the grid again. Also worked on having faster algorithms. This is an example. I imported over 10,000 polygons from a shapefile and used it to assign values to each of these grid cells. With ModelMuse, it took about 2 seconds. With Argus 1, which some of you may be familiar with, I used more or less the same grid, not exactly, but it took 83 seconds there, so that's a speed up. Now, not everything is going to have that same degree of speed up, but I do believe, and other people have told me, that it does seem a bit faster. ModelMuse supports a number of programs: ModFlow 2005, Fast version 1. Fast version 2 just came out. There are some new features in it that are not supported yet. ModelMuse supports ModPath and Zone Budget, but it doesn't support ModFlow 2000. And there are a lot of variations or extensions to ModFlow, like local grid refinement, groundwater transport, CWAT, what have you, that are not yet supported. So if you need those things, ModelMuse probably is not for you. As far as the packages that are supported, well, it supports nearly all. Here are the ones that it supports. Here are the ones that it doesn't. So it doesn't support multi-node well version 1, but it does support multi-node well version 2. It doesn't support the stream package, but it does support the SFR, the replacement stream package. It doesn't support the interbed storage package, but it does support the subsidence package, which does everything that IBS does. And when you first start ModelMuse, you'll see a dialog box like this, in which you can choose to create a new ModFlow or fast model, open an existing model, import a ModFlow 2005 model, or open any of the last 5 models you've worked with. Then you will get to the main window for ModelMuse. You'll see the main menu, buttons, a top view of the model, front view of the model, a side view of the model, a 3D view, and the status bar. You'll see information about the model down here when you move your mouse over other parts of the main window. Zooming in on the top view of the model, it has a number of parts. It has this working area where the grid and the objects are displayed. It has rulers which tell you where you are. It has what I call a selection cube. For the top view, it tells you what layer you're on, and you can also use that to change which layer you're on. You also notice there's some colored grid lines. This green line, for example, is a selected row, and here's this green square down here. That also shows a selected row. The red line, the red square, shows a selected layer, and that's shown in the front and side views. This is a selected column here, and there it is in that selection cube. If I wanted to go up a layer, I could just click. You could click there. If you wanted to go down, one concept in ModelMuse that's a little bit different than it is in ModFlow is the data sets. So in ModFlow, you have 2D arrays of value, for example, for hydraulic conductivity, and you'd have one of those for each layer. Well, KX is the hydraulic conductivity, but it's a 3D array. It has values for every layer. These values can be set with a formula like that, or you can interpolate values, and the values can be displayed on the grid. Here's an example of the grid. The grid has been colored with the value of a data set. Mostly when you are working with ModelMuse, you won't use formulas to assign values, but you will use objects instead. Object is a point or a line or a polygon, and they're used to assign values to data sets. They're also used to define boundary conditions such as wells, drains, rivers, streams, what have you. You can draw the objects in ModelMuse, or you can import them from shape files or other sources. And you can have these objects on any view of the model, on the top view, side view, or front view of the model. Here, for example, is an object that's drawn on the front view of the model. You see it on the top and side views as well. So these objects have 3 dimensions. They have an extent in the dimension perpendicular to the screen. How far they go is determined by formulas. One formula for the top, another formula for the bottom. You might wonder why you have this little cutout here. If you'll notice, here's a selected layer, so that's what you're looking at up here, and the selected layer actually goes a little bit below this object and then comes back up into it. So here it's coming down, it's hitting the edge, and then it's dropping down below this object, coming back up and hitting it again, and then going out. I'm going to show a number of the commonly used dialog boxes here, and then we'll get to a demonstration. So this is the ModFlow Packages and Programs dialog box. It's where you would select your flow packages, solvers, all the other packages that you might want to use. If you want to use ModPath or Zone Budget, you would expand this, and they would be listed here. Use it to define things like parameters or other non-spatial data. To define the layers, you go to the Layer Groups dialog box, and here, for example, is a confined layer. Here's a non-simulated layer. Here's a convertible layer. So you do all that in this dialog box. If it's an active layer, you would be able to assign a number of other properties to the layer. To set up stress periods, you go to the ModFlow Time dialog box. You set the starting and ending time, the length, the multiplier. And one thing that's a little bit different than it is in ModFlow is that instead of setting the number of steps, you set the length of the first time step, and then it calculates this number. The reason it does that is, if you recall, I said that ModelMuse might want to insert additional stress periods if you define a time that doesn't match any of the times you defined here. If you define a well, for example, going from time 0 to time 5, it would need to insert another stress period. And this way of specifying the time steps is more compatible with that than setting the number of steps. Another dialog box that I use a lot is the Show or Hide Objects dialog box. Any object that is visible will have a check mark next to it. And if it's not visible, it isn't checked. You can change whether it's visible or not here. It doesn't show it here, but if you have an object that's selected, it will be shown with bold type. All the objects are listed in this list, but then they're also listed according to what they're being used for. So here are objects that are being used to specify a boundary condition. Here are some objects that are being used to define the top of the model. You can also just double-click on an object here to edit it, or right-click and then select it. You can import from a variety of sources. You can import shape files. You can import an existing ModFlow 2005 model, surfer grid files, gridded data, images, and a number of other things that I won't go into. You might want to use ModelMuse for some parts of your model, but then it might be convenient to do other parts with some other tool. The ModFlow name file dialog box is set up to allow you to do that. Now, you can ignore this dialog box entirely if you want to. In that case, whatever you've defined in ModelMuse, that's what will be included in the name file. But if you want to, for example, create the evapotranspiration file with some other method, but still have it activated in ModelMuse, you could just do that and then put the line for the EVT package in here, and then ModelMuse would skip it. It would just put that line in the name file and run ModFlow that way. Suppose you had 200 stress periods and you had different evapotranspiration rates in each one. Well, it might take a long time to generate that file. So you can have ModelMuse do it once, put the line for it in here in the dialog box, and then it'll just use the old one when you try to run the model. When you actually run ModFlow, it's going to look a little different, because instead of running ModFlow directly, it starts this other program called Model Monitor, and Model Monitor will then start up ModFlow, and it will read the listing file, read the output that would normally go to the screen, and it will plot the percent discrepancy in the water budget. If there are any error warning messages, it will print them on the listing tab. What normally would be displayed on the DOS window would be displayed in this Monitor tab. Now in this case, the model didn't do too well because we've got a high percent discrepancy. So even though it's still able to run, we might not want to continue this model. So this lets you look at that data, decide, okay, I just want to quit and fix that and not waste my time with it anymore and kill it. Once you're done running the model, you can display the results from ModFlow and ModPath, color the grid with the data from ModFlow, like heads, also drawdown or budget terms. You can display path lines from ModPath. To help make ModelMuse easier to learn, there are a series of short video tutorials. And when you first start ModelMuse at the beginning of the day, it will open up a web browser and play one of those that you haven't seen yet. You can turn that off if you want to, but it gives you a short tip about how to use ModelMuse. Most of them are approximately 5 minutes in length. The very first one is 15 minutes, but that's the longest one. Limitations. ModelMuse can use a lot of memory. Those explanations, for example, you have to store a lot of data with that. If you have hundreds of stress periods, exporting or displaying the transient data can be slow. Project files can be large. You can save it in a compressed form, but even so, it might still be large. Imported ModFlow models can be especially large and slow. When you import a model, it brings in all the information, and you can work with it, and you can display it, and it can help you understand the model, but it might not be in the form you'd really want to use if you were really wanting to make major changes to the model. You can get ModelMuse from the Groundwater Software web page, and here's the direct URL. Well, how about we take some questions first, and then I'm going to start a demonstration. Does anyone want to say anything? I guess not. All right, well, let me close this, and I will start ModelMuse. So here we are. I'm going to start a new model, and I'm actually going to be reproducing one of the examples that come with ModelMuse. So let me show you where to get it in the help if you want to. I don't recommend you try to follow along exactly as I do this, because I'm going to be going probably faster than you want to go. But this will at least show you where to find it later on. You go to open the help, go to examples, ModFlow examples. This is the Rocky Mountain Arsenal. I want to show you one thing from the help. Here's our site map. You have a lake in the top, you have a river in the bottom. The head here is 75 meters. The head here ranges from about 3 meters on the left to 25 meters on the far right. This is a bedrock outcrop that confines the area to be modeled. There's one on the right, there's one on the left, there's two that stick up in the middle. There's a disposal pond that has water coming in at a rate of 0.025 cubic meters per second, and then there are two extraction wells with rates of 0.001 and 0.002 cubic meters per second. And so let me just create the model. And we're going to have just a single layer. Now if I were to click Finish right now, it would create a grid with 10 rows and 10 columns in one layer. But I'm going to click the No Grid button instead. We get ModelMuse opened up with just a blank screen. So the first thing I want to do is import a background image. File, Import, Image. I select the image. And it's saying I can either click on here and enter the coordinates, or I can just fill in this information if I know exactly what pixels correspond to what real coordinates. So if I wanted to click here, I could put in 20,000, 30,000. And after I've done enough of those, I can click OK, and it'll put the map or the picture where it's supposed to be. I'm not going to actually do it that way because I have the information that I need right here. So I'm just going to copy that to the clipboard. And the next thing is a little bit strange. I'm going to paste it into Excel and then copy from Excel into this table. Now, the reason I went through Excel is because that's what works. If you copy directly from here, it doesn't work. Excel puts it in a format that this recognizes. Essentially, each row is on one line of text, and they're separated by tabs. So that's what I need. Now, there's a black dot up here corresponding to this pixel, and I say it's at 1699,000. If I go down to the other corner, here's another dot corresponding to this pixel with those coordinates. So I click OK. There's the image. I'm going to zoom in a little bit. Actually, zoom in some more. Well, you can't read it too well. The text actually isn't real good there. You know, that's cute. That should be a 3, but you know, it's enough to go back to where I was. Now I'm going to import some shapes. Import a shape file that has some of the data I want to use. So here's the shape file, and I'll click that. Actually, I'm just going to import the geometry of the shapes. I'm not going to import any data with them. And I mentioned that these objects can extend in 3 dimensions, so I'm going to define the upper Z coordinate as being the top of the model, and the lower Z coordinate as being the bottom of the aquifer. I guess I didn't change the name of that. I was planning to change the name of that to something other than upper aquifer, but I forgot. Oh well. So I click OK. Hide this. That looks a little different now. I'm going to hide the image. And there are the shapes that we've imported. The next thing I want to do is to create a grid. And I'm going to do that by first drawing an object around the outside of the area that I want to model. So I'm going to do it like this. I double click here, and I'm going to call this the main outline. I'll use this to set the grid cell size to 100. I'm going to click OK. Click this button. I want to have a grid angle be 0, so I'll just click OK. And there's our grid. Now I want to decide which cells are active. Well, let's first of all color the grid with what's active. And by default, that is going to be every cell. I can show you that here. Move that over here. As I move the mouse around, you can see that in this dialog box, the layer, row, and column are changing, but the value is always true, and it's set by this default formula, true. What's this default formula? Go to Data, Edit Datasets. Here's the active data set. There's the default formula. Well, let's change that to false. I'm going to make every cell inactive. And now every cell is inactive. Okay, let's change all the cells that are inside this domain outline to be active. So double click on this, go to Data Sets, change this to true. But I need to do one more thing. I need to set the higher and lower Z coordinate. And I will set it to model top. Oops, why didn't that work? Okay, and aquifer bottom. If I hadn't done that, the object wouldn't have actually enclosed the grid cells. It would have been sitting on top of the model. So there, the cells inside are active, the cells outside are inactive. Now I want this area that's enclosed. Let's see, there's some other object I want to hide. Oh, I did the wrong thing. I hit the wrong button. Fortunately, I can just undo that. Okay, I want to hide this rectangle here. I selected objects. Now I want everything inside that to be inactive too. So I'm going to go data sets, required, hydrology, active. I want it to be false. I'm going to click OK, and it's not going to happen. Now why is that? Well, here it's this object is named RMA1. If I go up here, it says, false enclosed by RMA1 with formula false. Here, it's enclosed by the domain outline with formula true. So the domain outline was created after this object was imported, so it's overriding the value assigned by this object. So how can I fix that? Well, I right-click, select to front, and now it's come in front of the domain outline, and it's applying the value it ought to. So I want to do the same thing with some other objects here. First of all, I'm going to hide the domain outline, and then select all these other objects. Click on one, press the Shift key down, click on another, click on another, click on another. I'm going to do all these at once. Data set's active, false is what I want it to be. And then I select bring to front, and there they are. So now we've got the active area set properly. The next thing to do is to assign the specified heads. Well, there's this lake up here which has a head of 75. First of all, I have to activate the CHD package, the time variant specified head package. So I activate that. I also know that I'm going to need to activate the well package, so I'll do that. Click OK. And now let's make this a specified head boundary. ModFlow, I'll set ModFlow features, CHD, set the number of times to 1. My starting time is -1. The ending time is 0. That's by default. I have a steady state stress period extending from -1 to 0. And these are both going to be 75. So I selected both of those. I should explain how I did that. I clicked on one, held down the Shift key, and clicked on the other one, and everything in between got selected. And I'll type in 75. And that filled in both of them. Click OK. Let's see, I think it would be useful to take a look at what the CHD package has now. So if we zoom in up here, all those cells that are enclosed are now CHD cells. And I want the river down here at the bottom to be a specified head as well, but I don't want just a constant value. I want to range from 3 over here to 25 at the other end. Here's one way of doing that. I click on this button, and I can associate a value with this particular vertex. So I'm going to assign a key here, which can be any text. Let's say river stage, and have a value of 3 here. And make this, do the same over here, make it 25. Let me zoom in on this just a little bit because I want to show you one thing. You notice that this is the vertex that has a value associated with it, and it has a diamond. Here it's a square. It doesn't have a value associated with it. Undo where I'm looking, and double-click on the object. I'll make this a CHD. Use the same starting and ending times. And we'll use a formula. Functions. This is object interpolated vertex value, and then I enter the key in double quotes. Here's the diagram. Oh, here's an interesting, useful thing too. Interpolated vertex value. When I select it, this help button becomes active. If I don't have, well, and then I can click on that, and here's an explanation of what that function does. And what it does is it interpolates along the length of an object between the vertices that have values associated with it that have the right key. So I don't need that anymore. Click OK. Let's spread that out. You can see that there's the formula there. I'm just going to copy it to the clipboard using Control-C, paste it in here with Control-V, click OK. And you can see that there's change in the color here as you go from one end to the other. Here it's 3. Up here it's close to 25. The 25 is actually a little bit beyond the edge of the grid. That's why that's not exactly 25. The default value for hydraulic conductivity is OK, and the hydraulic conductivity in the y direction is going to be exactly the same, so I don't really need to do anything about that. I'm going to use a confined layer. I'm not going to worry about the initial head for that reason. So there really isn't much more to do, except I still have perfectly flat top and bottom, so I want to change that. I want it to be around 75 up here, and I want it to be just 1 meter above the river in the south. Okay, so let's look at the river first. Okay, I would like to set the top of the model here, but I can't because this object depends on the top of the model. You can't have the same object be dependent on the same thing it's setting, so I can't use this object directly. However, I can just copy it to the clipboard and then paste a new copy. Here it is. I'm going to turn off the CHD package here, and I'm going to change this to use 0 formulas for the Z coordinate. That means it's no longer depending on the top or bottom of the model. And now I can go back here and set this. So I can still use the same function I did before, interpolated vertex value, river stage, and then I will just add +1. So now it's a plus. It's adding this interpolated vertex value to 1. Click OK. And I want to interpolate those values. Click Interpolate, or set values by interpolation. Now I'm going to get a warning message here. Warning, you attempt to specify the value of the data set by interpolation, but at least one of the data sets, model top, does not have an interpolator assigned. Is this really what you want? And I say yes. Okay, and now I have to go back to model top here and assign an interpolator. And I'm going to assign this one. All right, now you see it's not perfectly flat anymore, but let's look at what it does look like. So it's just more or less a gradation from one side to the other, but I want it to be much higher up here in the north. So I'm going to make another object up there, and it will be assigned by interpolation as well. Have a, I have to do that, model top of 75. So now if I look at the grid values here, it's close to 75 near the top, comes down here, gets down around 4, close to 4 down here. Okay, so here you see it from in the side view. I want to make the thickness exactly 12, so I will go back in here and set this to the model top minus 12. Okay, now you see that. Here's a 3D view. If you watch this as I move this along, you'll see that the different cross sections, the view is slightly different. Let's see, view. I don't see it down any of the model down here, and the reason is it's too far north. Too far up. Here at about 60, and it only goes to about 10 here. So I want to see the front a little better. So I'll go to that location in the front. There it is from the front. So now the model is almost ready to go. I still have to specify these wells. Right here, that was the disposal pond. And let's see the image again. I think that would help. Well, I can't really see the image through the colored grid cells, so I want to turn those off. And actually, I don't want to see all the grid lines either right now, so I'm going to just show the edge of the active area. Let's zoom in here. So here's my object, and it is supposed to be a well with an injection rate of 0.025 cubic meters per second. What set values for closed cells? Well, let's see, 0.0225. Remember that positive values are injection. And here's one other thing I'm going to do. That's the injection rate for the entire well. So I want to change this to total, and it will divide that amount up according to how much of each cell is in that particular object. So here we have a number of different cells that are all partly enclosed. Actually, I don't want this enclosed. I want closed and intersected. So let's see what we get here. Look at the well pumping rate. So data show grid values. Move this over here. Here it's 0.0097, 0.0094. Those add up to about 0.019, and then there are a little bit in each of these others. And if you added those all up, it would add up to be 0.025. So I'm going to go back to that. And now I'm going to zoom in on the 2 extraction wells. I will put one of them here. And that one has a pumping rate of minus 0.001, minus 0.001. Okay. And here's the other one. Minus 0.002. Okay. And now we'll go ahead and run the model. Well, actually, I'm going to save it first. And here's a little thing I want you to remember: create archive. going to go to My Documents, RMA temp for Rocky Mountain Arsenal, RMA, save it. Now I'm going to run the model. It's going to take the name of the file that I just saved and use that to assign the name of the root name for all of the ModelFlow input files. Click Save, and it says Execute Model. So if you just want to generate the input files without running the model, you would uncheck that. But I do want to run the model, so I'll have it checked. Click Save. It's generating the input. So here's ModelFlow. It's a single stress period. It's all done. There weren't any problems. Close that. Now let's open the listing file in Notepad or another text editor of your choice. I'll close that. I don't really want to look at it. I'll close this window. So there was a warning that popped up. The initial head is below the bottom layer in a whole bunch of cells. This is a confined layer, so ModelFlow really doesn't care what the initial head is or whether it makes sense or not. And now let's import the model results. I'm going to go File, Import Model Results. It has the right one. This is the heads selected by default. This is drawdown. This is the budget file. Open. This is, we only have one stress period, one time step, so it's only one set of data here. I'm going to color the grid with the data set I'm importing. Click OK. And there is the heads and the final time step. We could use ModPath with this too. I'm going to go Model, ModelFlow Packages and Programs, activate ModPath, and I'm going to do path lines. OK. I'll make the disposal pond a source for the particles. Turn this off. ModelFlow features, ModPath, and I'm going to have, for each cell, I'm going to have 5 particles in a row, 3 rows. I'm not going to have any in layers, but I could have them in other arrangements as well if you wanted to, but I don't. Click OK. Now run ModPath. File, Export, ModPath input files. And let's run ModPath. Here's the output from ModPath. Everything seems to have exited properly, so we'll close that. And let's look at the what those path lines look like. Import ModPath path lines. Here are all the path lines. I want to now some of these paths are intersecting that supply well here. So maybe what we could do is we could have a horizontal flow barrier connecting these two things and block it off. Let's just see if that works. So I'm going to do activate the horizontal flow package. Okay. I'm going to draw a barrier from here to here. I'll accept that. I'm going to have I'm going to have it adjust the hydraulic characteristic to account for the fact that the length of the zigzag line that ModelFlow will use to find the barriers is not the same length as the diagonal line that I drew. At any rate, let me show you what the what that would look like, how the horizontal flow barriers would be done in ModFlow. First of all, I'm going to hide the path lines, and I'll zoom in here, color the grid with the horizontal flow barrier, and here are the horizontal flow barriers that ModFlow would use, and it's not the same length as the line that I drew. So to account for that, these have been adjusted a little bit. These have been reduced quite a bit. These have been reduced just a little bit. So let's rerun the model. Okay, and that ran just fine. This is I don't know whether you call it a bug or not, but what happened is that it looked at the output from the previous model run, which was saved to a text file, and then when ModFlow ran, it generated a new text file, and it got data from both of them. At any rate, well, there wasn't any problem when ModFlow ran, and we'll close that, close this, close this. We'll run ModPath again now. Okay. And let's look at the mod path. Now this is going to be exactly the same file name as before. So when I click OK, it says the file on the disk is a different date than the one that was imported. Do you want to import the new file? I'll say yes. And here is the new model. And you'll notice that it not only did putting the barrier here not prevent the solute from getting to this well, but what happened there? Let's zoom out a little bit. But also, now we're getting stuff coming to this well as well. So that didn't work too well. At any rate, that's enough for the demonstration. Minimize that, and now we can have questions if anyone has any. So anybody there?
Yeah, I think we're here.
Okay. Does anyone have a question? You could, if for some reason you can't just say it into the phone, you could send me an email, and that will work too.
One minor question. Can you show us that directory where all the input files are?
Yes. Yeah, right here. Okay. Oh, that reminds me of something. Let me save this model again. I'm just going to do save, and we'll look in the directory, and there's a zip file there. And what it has is it has the model here, and it also has all the input and output files from the model. It has a copy of ModFlow. It has a copy of the files that I imported. I don't know why it's calling these directories, but they're not directories. So what this is the start of an archive of your model. All the files that are going to be included in the archive are listed in this dialog box. You could delete them if you wanted to. You could add more. And there's also a link here to the USGS model archiving policy. So if you want to check on that and see exactly what you need to include, you can just click there.
So one thing I noticed is you didn't have to tell, other than the particle, unless I missed something, other than the particle locations, you didn't really have to tell it much to generate the ModPath input files.
No, I could have specified a zone where it was going to stop, but I didn't choose to do so. I could have just drawn something like this and said data sets.
But basically, my sort of short question is, it's just pulling all the information it needs from the other input files.
Yeah.
And to save that information about the particle starting locations, all you did was you went under File and then Export, did I see?
Mm-hmm.
Okay.
Are there any other questions?
Yeah, hey, Richard.
Yeah.
This is Dorothy. You might want to let everyone know, like, what's on the list of next for compatibility with ModelMuse, because there's a lot of stuff out there, and I'm sure there are a lot of people saying, hey, can you make ModelMuse work with this, that, or the other thing?
What I was thinking of doing next is local grid refinement, but I'm open to suggestion. Either you just say something now, or you could send me an email.
We like that idea.
Okay.
Are you using LGR for something?
Yeah, we will be. We're working on it now.
Okay. It's probably going to be anywhere from 5 to 9 months before that's done. There's quite a lot of stuff I'd have to do for it.
Yeah, that's okay. I mean, we were planning on just generating our grids and populating our models with ModelMuse.
Okay.
And then doing the LGR specific files and running everything outside of ModelMuse.
Okay. Do we have any other questions?
Hi, this is Bryant from California. Can you hear me?
Yes, I can.
How difficult would it be to convert this model to be compatible with FAST?
Well, the main thing that is really different between, well, the two main things that are really different between ModFlow and FAST, and one is the grid and the other is the boundary conditions. In FAST, you can't have layer tops or bottoms that are anything other than flat horizontal surfaces. So you'd have to make a new grid. But the objects for things like KX and KY, you could still use. And the boundary conditions, like the well package doesn't really match up with how wells are done in FAST, so you would need to redo those. But certainly, if for a lot of things like the aquifer properties, those would translate over to FAST pretty well. Does that answer your question?
Yeah, thanks.
Okay. Anyone else?
Yeah, this is Don Poole in Tucson.
Mm-hmm.
You showed how to create tops and bottoms with some points and some interpolation. What about bringing in a surface? Can you do that?
Yes. Well, there's a number of ways you could do it. If you had a shape file that had a series of scattered points, you could bring that in and interpolate. If you had something that had a value for every cell, either as a shape file or as a spreadsheet where you had XYZ coordinates, and you could import it that way. You could do file, import, let's see, gridded data right here. You could select, for instance, layer definition, model top, and then you could, if you had a spreadsheet with all the values for each cell, you could just paste it into here. So that there's a number of ways of doing that. There's one of the interpolation methods is just nearest point. So you have a point at the center of each cell, and it would grab the value off of that point. Any other questions?
Hey, Richard, this is Steve Marstrom.
Yeah.
How much of a like a GIS kind of background is this using? Are your objects geo-referenced? Is there that kind of a concept in here?
Well, yes. I mean, these objects, there's a series of vertices, and the vertices all have XY coordinates. They're, in this model, it's not, this isn't sort of like UTM coordinates where you'd have much larger numbers, but, these are coordinates. You could use a different coordinate system and have, whatever values you want. Now, all your data has to be in the same coordinate system. You can't use, state plane coordinate system for some data and UTM for something else. That just isn't going to work.
Okay, yeah, that's kind of where I was getting.
Okay. I mean, if you do have data in different coordinate systems, probably the best thing to do is to use a GIS to put it all in the same coordinate system before you try to import it.
Okay, thank you.
Mm-hmm.
Hi, I have a question. Lois Rollins from New Jersey.
Mm-hmm.
I was wondering, can you make a cross-section if you have a model with multiple layers and you have the tops and the bottoms?
Oh, sure. Yeah, I mean, a cross-sectional model where you just have one.
Not a cross-sectional model. I mean, just to be able to check the layers to make sure that they don't cross anywhere.
Well, you have a cross-sectional view right here, which actually I'm zoomed in so much you can't really see it too well. If I had multiple layers, which I'm going to do right now, I'm going to make this 2 layers in that one group. Now you see 2 layers. So you could, if you could check each different one, but also when you export the model, ModelMuse will check for any layers that are not kosher. That the top of one layer is below the bottom of the below the bottom of the same layer, below the bottom of some other layer.
Oh, great! Thank you.
Mm-hmm. Any other questions?
Hello.
Hello.
Oh, good. Hi, this is Linda from Lawrence, Kansas, and I have a couple questions. One, are there any size limitations on using this? Size limitations as far as number of models, grid squares or grid cells?
Well, the biggest I've been able to do was a 3 million cell model that Ward Sanford had developed it, and I imported it in here, and I was sort of just barely able to work with it. The main thing that's going to limit you is the amount of memory. I mentioned that ModelMuse can use a lot of memory. I have a 64-bit computer with 6 gigabytes of memory. ModelMuse is capable of using up to 4 gigabytes. It's a 32-bit program, and that's the limit for a 32-bit program. So I mean, 3 million is really pushing it. A number of people are using it with. I'm trying to think what Dick Yeager's model is. Like 180 by 150 times 10 layers. I'm not sure what that is offhand, and I don't know that those numbers are exactly right. But what is that? That's 270,000 cells. It doesn't. There isn't a built-in limitation. It won't say, okay, this is too many layers, too many rows, too many columns. It'll just, if you try to put in too much, it won't be able to do it.
Okay, thanks. My other question is kind of along the same lines as another question someone else had a minute ago. But if you have a shapefile of well data, can you import that just all at once? Say you have 500 wells.
Yes, you can. That's and a number of people have done things like that. So yes.
Okay, thanks.
Other questions?
Well, if not, that was very helpful, Richard.
Okay.
Good introduction to ModelMuse.
All right. Well, then we'll end the webinar. I was recording that. If you logged in early enough, you will have seen that on the screen. And we'll see about getting this up on the web in fairly near future.
Good.
Okay.
Well, thanks for taking the time to prepare this for us.
Thank you.
Thank you.
All right, take care.
Thank you. Thanks.
Thanks.